here. Just make sure Twitch and YouTube are running properly. YouTube Studio.
And she killed.
Thank you, Twitch. I love autoplay on your homepage. It's so much fun. Okay. We're gonna go to Creator Dashboard. Manage Stream. Yeah, okay. And we're gonna set category. Why is it set to Dark Souls? Fuck. I remember how you do this command. Change Twitch stream category. Edit stream info. Oh, here. Cut off Dark Souls. I don't know why it's on. Game development. Software and game development. There we go. Done. Why does it have the war? Oh, I left the Warhammer tag on. Okay. We'll add roguelike. There we go. We'll add horror. And we'll add one more. What's another? Roguelike, horror, and turn-based. There we go. What is the YouTube category set to? Does YouTube have categories? Actually, I'm not sure if it does. Hold on. Have categories. Thank you. Me. Edit video. Does that let me edit the stream category? Playlist. Audience. No, we're not for kids. Thumbnail. Analytics. Copyright. Customization. Surely there's like a category thing, right? Does YouTube have stream categories? Okay, I am not seeing it. I see playlists. Fuck it. For now, it's fine. We'll close out of that. And stream is up. Looks like audio is good. All right. Back at it. So in case anyone's watching for VOD, I'm working on this little project, trying to fuck around with some ideas. I'm making a real-time turn-based game, and I'm trying the Unity ECS framework, which has if you don't understand what that means, basically just know that the parts that make up an idea, like an enemy, are split across components, and then you modify those components separately. And right now, I'm trying to get the turn system working. Because it's a real-time turn-based system, the turn system is decently complicated. To put it, basically, round starts, and we start with highest speed thing. Their turn goes. Whoever didn't go, so enemies or player, the other gets to react before, which will resolve before the thing. So there's like animation cue that starts playing of like, oh, this is what we're doing, and then the other side gets to start figuring out how they're going to respond. And then once that's done, we cue the last bit of the animations, wait for a resolution, and then process the next highest thing. So that's kind of how it works. There's going to be some stuff that complicates this, so who's allowed to react is going to depend on like a speed differential, which I haven't fully integrated yet, and waiting for animations to queue versus like running background processes so that not everything has to happen in one frame is going to be a little bit more difficult. And then I'm pretty new to ECS still, so we're going to run into a few things there, but more or less, that's the idea. Okay, so right now, what we have... You like this auto switch, by the way? Figured out how to set that up today. I was pretty happy with that. Oh, it blinks. I wonder if there's a way to... Hold on. I wonder if I can order the macros on this switcher such that it doesn't blink. Where we enable this one before we disable the Unity one. Yeah, I wonder if that will do it. It still kind of looks like it's blinking. Okay. But anyways, so we have our Uni project. So what we currently have set up is that on boot, we're going to generate out a run, which right now is just nothing. It's just empty. But we spawn like a few guys. Currently, we just spawn, I think, the player and like 2 enemies or 3 enemies. And then what we do is we start the turn system. Turn system tells us what mode we're currently in, so it'll be like queue the proper agents, basically. If it's the player that can get queued, we queue the player. Otherwise, we queue the enemies. Then they'll run their given turn. Then we're going to throw that data into a queue system so that we can store that value, basically. And then we need to then ready the next set. Actually, hold on. No, this is correct. I don't know. Yeah. For a second, I was like, wait, do I need a queue system? Because I can just store the queued data on the individual once they finish it, but that's not the case, because you need to know a hierarchy of the order in which they're resolving. So the queue system is actually here to make sure that that order is properly set in motion, which is what we're doing right here. Nothing too complicated. And then... we're going to need... So we need to add a visuals hook in. And then we need to wait for the visuals to resolve, whatever that looks like. And then we're going to have an actual action resolver. So there's like a massive index of possible turn actions you could take that then processes the prerequisite action. And then there's going to be... we're going to have to probably shift the turn, like when things are processed around a bit. So right now, everything runs on one frame, right? We're not queuing anything. We're not running any background processes. Because the way that you'd want this to work, which is what I'm going to eventually do, fill in the black background, because black backgrounds are better. But what you'd want it to do is prep hold on, let me restart. This is how it currently works, is the thing begins, and we say, okay, it's the enemy's turn, so the enemy's going to go here, and then the player then responds right here, and then, I should make that a box so it's clear. So then the player will respond here, we'll make that a triangle, and then we resolve them, so that'll be a circle. But we're doing this at one frame, right? So the second that the enemy's able to go, we do that, then we do the visuals. Then the second the visuals start, the player can start doing their response, and then once everything's done we process the action, and then we move on. But what would actually be nice is to do this such that the next enemy code starts the second that the previous one ends. So that way, okay, so it's, in this case, it's enemies, then player, then enemies. Well, now it'll be the player's turn, theoretically, possibly. And so then the player will need like X number of seconds or in frames that it's not might not do, right? You might be like, oh, it's my turn, I'll leave my controller, set it to the side, or you're sitting there for a second trying to figure out what you'll do. In this time period, we have just empty frames where nothing is being processed that we could put a background task in to figure out what the enemy will do ahead of time, so that whenever the player does their input, we can immediately respond to it, as opposed to stacking everything on this one frame to then begin queuing the animation. So that's the idea. We're going to do that, and then for a enemy turn, it'll be fairly similar, where we start the queuing of it the second after, right? So in this case, let's say it was an actual enemy turn next instead of a player turn. Then we can start on this frame. There's going to be a few frame. We would start it before the visuals finish is the idea. So while the animation's finishing for the last turn to go, we are prepping the data for what the next turn will be, or at least what the AI is considering. So, yeah, and then basically we'll have a sync point. So if it's the player goes first, then the enemy just holds on to all its possible turns to react with. Or if it is the enemy's turn first, then it queues its best option and then dumps the rest, and then waits for the player response. Based on the player response, then we do the next. We might do something, depending on how expensive it is, where we keep the data of the valid arg. So, like, let's imagine enemy thinks and it considers, n possible outcomes. It's like, okay, if the player does this and then I do this, here are all the possible actions that can occur. If the player then chooses this branch to go down, then we might not actually want to dump, or we might not actually want to start completely over when we start from this point, because it could be that we've processed 7 turns ahead, and now we would be losing all of this branch data that could stem from this. So we might instead truncate it to clip out the sections around it, and then keep the branch that's still valid. I haven't fully figured out if I want to do that yet, because you're only going to really want to do that when you're really optimizing. Let's put it this way. I'm going to start off not doing that, but the difference between not doing that and doing that isn't much, because all we're doing is just storing the data and then just shifting it forward a little bit. I just need to make sure my sculpting is right, or like my tree trimming is correct. So it would more just be how long it takes me to implement, and so if I don't need to, I won't. But if it's a noticeable performance increase later on in the project, I absolutely will. And the big thing is just how much memory it's going to take, and then how much time it takes to process this out. But if it's worth it, keeping that might actually be entirely worth it. Part of the other issue, though, is that I don't foresee this point ever being valid, because it's actually kind of a meme. It's the 3-body problem, which is like, let's say that the enemy knows all the possible player actions, which is what I'm currently doing, right? So we have all of the possible player actions. So that's swing up, swing right, swing left, swing diagonal in every combination, move in every combination, turn in every combination. Let's say that we had that big bucket of actions, and let's say we had all of our enemy actions, and then let's say that we iterated through them, where we considered every possible world that intersects these two, all combinations. Okay, now that we've done that, we would then know that, oh, if the player did X thing, that we would know which action we'd want to do, and we would know this timeline ahead of time. And if we had done like depth 4 or depth 5, then we could still hold the relevant data for the future. But the issue is that if we add a second enemy, now this enemy has to consider itself and the player and the other enemy. And so now we have a 3-dimensional issue and that just scales with every single enemy that's in the game. So I don't really see storing that as a viable option, just because I think eventually the data will be invalid every time, and that wouldn't really be worth the filtering process. But maybe that would be the case, and then we could look into it. I just don't see an easy way to do that, and that seems like again, only when necessary a thing. So right now, what we did is I just hooked up the input validator. So what's currently happening is the input system is at the very beginning of the frame. We read the values of what the player's inputting, and then we do the turn system, and then we do the enemy and player action feed. So the reason that we've split this between the inputs and the player action is that I want, if, like, let's say the input is pause the game, well, that's not like an action that we want to queue. We don't even want to remotely consider that. If that is a thing, we don't even really want to bother with doing the rest of the frame because it's going to be wasted time anyways. So basically for all of the non-gameplay specific aspects or inputs, we're going to store that to the side. Let's imagine you could open your map at any time, for instance. That might be a thing. And so we're going to do that over here. And then after the turn system's set up, then we'll read the inputs. Because it might be the case that, or not read the inputs, determine which action the inputs will do. Because if the player can't even respond that turn, why would we even waste our time? But the other thing we're doing is we're putting a validator here before the turn order. And the reason is that the validator is going to look at the world state, and it's going to determine which possible actions the player could do, this idea up here, which one of those are valid. So imagine if a player's up against a wall, the wall's to the right. Well, now move right is no longer a valid action, so we want to eliminate that from the possible consideration of both what the player's allowed to input and also what the enemies would even consider as a possible input. Because, and it's for both those things, right? So, like, the player doesn't want to... every time the player does an input, because it's a turn-based game, we don't want to burn an entire player's turn just trying to run into a wall. That's not really that fun, it's not particularly useful, and it can just cause a bunch of issues. So we just eliminate that from the player's option. But that means that if we didn't do it beforehand, we'd have to check it in real time, which we could do, but if the enemy is going to go, and the enemy needs to know that information anyways, we'll just do it ahead of time. So that's what I did. So the way it currently works is that we let me go over to the input validator. Where is it? Here. So what we do is we're going to we create a read-only data struct called a blob. I need to fully understand why they named it a blob, but you make a blob builder. You create a array of possible turn data. And so then what we do is we just check to see if it's valid, and if it's valid, it's allowed to be added. So then what we'll do is whenever the enemy goes to read this, we'll just give it that array, and when the player goes to perform an action, we'll compare what that action would be up against the value. I technically need to do another layer of this to incorporate direction facing, right? So like if which direction you're facing, it's going to dictate whether it's valid or not. You can't stare one direction and swing your sword at a 180. I'm probably not going to allow that in the game. So we're gonna have to do another validation there to see how that works. But I haven't quite figured out how I'm going to do rotation yet. So that's a bit of an unsolved thing, but it's currently set up to allow for it. We would just have to go in here and rework this slightly. So yeah, that's how we've set up that hook. And so when we run play, what I can do is I'll go up to here, and I'm going to put a breakpoint on that, and then attach this, and then that's it. Oh, almost, there we go, that's attached. We'll click play real quick, and it should hook in at any moment. Any moment. Huh. Oh, there it goes. It's just delayed. Okay. I was about to say, what the fuck's happening? Let me check my task manager. Alright, I love my computer. I'm so glad I have a modern computer that can do things. Alright, so we're totally fine on things. It was just a slow hookup. Okay, this is fine. So, if we go into the data variable, which is what we're storing, the value is null. Wait, fuck. Oh. Hold on. Why is this null? I was messing around with this recently and was like reworking it a little bit, so I'm wondering if I accidentally wrote off one line that was really important. So it was working earlier today. Was it today or yesterday? One of the days. Whatever. Okay, so let's go a frame. Maybe it's just the first frame that it's not properly doing it. Okay, it's still null. What did I do wrong here? We have it as read write. Maybe it's because it's on the dispose and we're erase conditioning our check. Let's disable this. We'll add a new line. Also, I need to stop running Unity. There we go. We'll say debug.log, test frame. That way we can add another key point to check for, and then we'll rerun. Oh wait, did I not save? I might not have saved. Now we'll recompile. Okay. Burst error. Maybe the burst error is what's causing it? I wasn't getting that burst error earlier. Well, why is it? Oh, there we go. That was weird. Quick play. There we go. Okay. Null, null, null. Okay, something is wrong here. Let's disable. Stop the debug. Let's check our profiler. I believe the action's running. Yeah, the action's running. And the validator has the data on it. So theoretically, you should be able to click play and then look at the entity mode. And wait, there's a hash on this. Maybe just the data variable's not being updated? Okay, we can test this. If we just go into... Get rid of that. we'll make a new line, and we'll say var data is equal to system API dot get singleton of type data. No, what is this called? Validate data. Recompile. So now what we'll do is we'll just read the localized new data. It does have it. Okay, so why isn't underscore data? Oh. I wonder if get singleton is only like on this frame or something. And so I'm only looking at the original frame's get singleton as opposed to a later one. Because this is correct, right? We have how many entries? 17, yep. So that's correct because we have 2 actions we're feeding it, and we've checked all 9 directions, right? Which is forward left, forward right, left, center, right, back left, back right. So that's 9 directions per action. That's 18 actions. So that would be correct. So we have the right data on this, but just that's not getting updated. Although it doesn't even look like we're referencing it right now, so we can just delete it. But it's good to know that that doesn't get updated like I thought that did. If that's the case, I might need to remove some of the variables that I have stored on my systems. Okay, so we'll delete. Nope. Delete that line. Delete that line because we don't need that. We still need this for update because that's what's dictating us entering this. Do we need the player? I mean, yeah, we do need the player for the validator, but we don't need to store the player like we were. We'll just, if it's not getting updated all the time, we'll just do it here because that's more convenient anyways. System API dot get singleton player dot value. No. Oh, this is going to be dot data dot ID. Right, we're getting job ID. Yes, okay, that's what we're doing. I should rename this so I don't forget that. Player ID. Yep. Okay, better naming. Alright, and that job is finished for now. So I think the next thing, so the current flow that we have hooked up right now. Let me pull up Paint again. Delete. There we go. All right. So the current flow we have is we have. Can I type this? Yeah. Okay. We have input, then the validator. Then we have turn system, which is set state. Then we're going to have the get turn data section. So that's both for player and enemies. And then we have the queue to just store those values so that they're not on the person, and then also we don't have to worry about like accidentally setting brace conditions or something, because I don't know how else you would set up a queue. I mean, there's a couple ways you could do it. If it's an issue or if I don't like the structure, I can change it later, but we're in draft 1 right now. We just want to get this playable. So then we have queue. After the queue, we need to add a visual system. So this part hasn't been done yet. So that's going to start playing the animation. And then we have in between here. Actually, that might be the queue system's job. I might make the queue system also process the actions. So if it's given a batch and it already has a batch, then process the one it got and then process the one and actually implement that into the systems. Otherwise, just store the bash, and then what we'll, or the batch, not bash. And then what we'll do is we will go over here and we're going to add, this is our cleanup system. So this is doing like double checking to see what the next state should be to help prep the turn system checker. It's purging all of our memory so we don't end up memory leaking. It's just kind of the background cleanup tool to make sure that everything does what it's supposed to do. So with that being said, what we're going to do is what will be the next thing to tackle? The next thing to tackle is going to be fuck it. Let's add a queue system hookup. We don't need the visuals yet because we still have nothing to show anyways. So what we'll do is let's go back to the queue system. I don't need you. I don't need you. Close you. Close you. Okay, and close you. Does data actually do anything on this, or can I also remove this as well? I think we can remove this again. Okay, so we'll move. Good. So we need queue data. That's our storage system. So we have that. That's always running or always ready. Then we have the action set, and then finally, if we're not visualizing. So if we're, running animations, we don't really need to do this because this is going to happen before the animations are resolved anyways. So if we're like spending multiple frames watching an animation play out, then we don't need to worry about this queue system. So what we're then going to do is we're going to go into queue enemies. Or no, we're going to check state. So what this should be, what does check state say to do? Oh, just to do. We haven't done anything with it yet. Okay. Oh, wait, we never fully set up this queue system. I totally forgot about this because we ran into issues storing stuff. That's right. Okay, let's do this. Let's set up the queue system and make sure that that's working properly. And then let's see if we can pass data through the system and make sure that it's processing it right. Yeah, that'll be a fun test. So the way the test will currently work is that we're going to, turn system's going to start. We're going to have 3 enemies. We're going to get their turns. Then they're going to queue them. Then we're going to go to cleanup. Then we're going to go to player react section. Then no matter what the player's inputting, we'll just feed a default data value to kind of fuck with it. Or to kind of fill in the gaps so that it would kind of simulate what our real turns are going to look like. And then the queue system will determine whether or not some data is already in the cache, and so it is, so then it's going to process them. And then we'll have some big database somewhere of possible actions, and we'll feed that to those. That's what we're going to do. Okay. Yeah, so that's how we're going to handle this. Yeah. Then let's go into... So in order to do this, we need to store data. So let's grab our queue data. How does our queue data set up? So yeah, so this is the correct solution. This is what we want to do. We want to have well, no, this is not the data. We don't want to store an array of arrays. We want to store just an array. Oh. No, okay. So one of the things that I was debating doing, and this is a design question that I still haven't quite figured out. Let's do Notepad, because I want to type this out. I don't want to constantly fucking fight paint. Okay, here's the thing. The way the current game is set up to be played, it's like over the shoulder third person, right? We're not like on like a zoomed out Final Fantasy Tactics map, and it's not like first person, although it could be kind of close if we get the vibe, if it's easier to conceptualize. Which means that rotation matters, and then the fact that there's monsters and you're kind of hide from them at some point. Imagine like an Outlast or something. Then rotation of visuals matters for both the enemies and also the players. And so we need to keep track of the direction that entities are facing when they're doing things. And so then the question becomes, what is the how do we handle rotation? Because in the current turn structure, your turns are only one action per turn. We're doing this to try to keep the turns quick and to keep the turns visceral, right? So we're trying to do this weird hybrid of making a game turn-based so that the input state is more limited, so that you can't do like cheeky shit like just slide up against an edge and like fuck with the AI because there's some like race condition happening in the system. But we're also trying to do. I'm losing my train of thought. We're also trying to keep it visceral, right? Because it's like a survival horror game, and you're trying to run around and fight monsters and shit. And so the idea is we're going to do one action turns. But how do you do one action turns when there is... how do you handle rotations? Because you don't want to turn to be the entire turn, because that's going to be really frustrating. Like if your one turn is swinging your weapon, and then the opponent's turn is turning to face you, that would be actually pretty good for an enemy. But for a player, that's going to be annoying as fuck. The enemy swings at you and your response is to rotate because they snuck up behind you or whatever. So I think it'd be nice if we could merge a rotation with an action. So the idea might be like, let's say there's a button on your controller. I'm currently theorizing that that's going to be like a left bumper. And so the idea is that you're going to hold left bumper and then you like move a direction, right? If you don't hold the bumper, maybe you turn and then walk forward in that direction. So let's say if I hit right, normally I would rotate 90 and then start walking that way. But if I hold left bumper, then I strafe. That might be how we implement it. There's going to be some idea that you can control your rotation independent of the action. Now, that's not always going to be the case. So earlier I mentioned you shouldn't be able to attack in one direction and be facing 180 the opposite. Maybe in very rare cases, but for like a standard sword swing, that's not really viable. And so what we need to do is we need to have... Hold on, I just had an idea. Maybe it is viable. I'm trying to think. Hold on. I just had an idea. What if you separated the direction of vision from the direction of facing? So maybe I'm always facing north, swinging north, but maybe my camera rotation is south because I'm like looking over my shoulder while I swing, right? I don't know if I actually want to allow that level of complex behavior, but that's not an assumption I should be making. So that's good to keep track of. But let's say it is the assumption that we're making. Basically, the point is that I want to try to... I think it's a good idea to make the rotation part of your turn input, such that you don't burn a turn rotating, and you also don't get like a free infinite number of rotations that you're able to just constantly do in order to bypass the whole point of having the perspective. So with that being said, originally I was going to store an array of data, so it was going to be stored separately. So like one was going to be the rotation, was going to be one action, and then the other would be the normal action. But now that I've merged those into one action, I don't... What the fuck did I just save? Did I just save this file? Hold on. I did just save this fucking text. Notepad doc. God damn it. Okay. Yeah, close. Okay. So yeah. Okay, I don't think we need this anymore. So I think we could just make that an array. And so what we'll do is we'll just go, so now what check state should say, shouldn't be called check state. It should be called, I guess check state works, it's fine. What we'll do is we will, if system API dot get singleton, this is going to be qdata dot oh, maybe I should make this, I think I have to make this value RO. Oh no, it's a singleton. Never mind. I don't have to do it on singletons. And then we're looking for .q. Is we're gonna do count. Is there no value dot count length. God, I hate having to hit value so many times. Is greater than 0. Then we need to process turns. We'll pass in the state just in case I actually need to do that. I was like doing that last. And then we'll pass in actually we don't even have to pass that in. We'll just pass in that. And then if it's else, then we need to queue it. So then we'll just do this doesn't have to be split between players anyways. We can just do queue actions. Okay, then we'll rename queue enemies to queue actions because I don't need to split that. We'll delete the yes. Why is it? Okay, I need to get better at these commands. It's gonna be that, and then it's gonna be there. And okay, I don't think we need those anymore. So we can get rid of this. Nope. Wrong command. All right, and now we can just go into here and we can add a first compiled void process turns. Alrighty, and then queue actions needs another reference to state, so that's easy. Oh, F. Okay, so now what we need is we need a way to store the turn data before it gets sent in. So the easiest way to do this okay, I know what we'll do. Let's pull up the enemy agent data. Okay, we have an action set which we're going to make a native array. We honestly could still make it a native array. I don't think there's any issues with that. We just have to make sure that on the spawn system, I was gonna say make it a blob because it's read-only technically, but I don't know if I want to make a blob asset into a blob asset into a blob asset. That seems a little weird. Maybe if I will later on, but for now, let's do. This is the data. I need the actual spawn system. We're going to go in here. And we're going to set. Is action set stored separately? It is. Okay. We'll go here. For each set in system API dot query ref read write of type action set set dot wait, hold on. I don't want an array of bytes. I want an array of turn data. Equals new, and we'll set the allocator to be persistent. Do you have to declare a size on these? Cannot resolve constructor. Candidates are currently existing native array and a components of .turn data, a size. Okay, you do have to specify size. What would be the max size that we'd want? So it's for the player, doesn't matter at all. The player can be 1 for all we care, but we'll keep it open just in case. But for the enemies need to store the possible. Maybe we do need to split this between the player and the enemies. So what the player is storing is just like their 1 or 2 actions that they've set up for their turn. But what the enemy is storing is a matrix of, or like what would be like a search tree of all possible player actions into their action. So with that in mind, you can't even store these as turn data. You'd have to store this as like its own thing. So what we'll do instead, let's make this easier. We're going to store a 24 users. I don't want to rewrite around this. Get rid of the baker. I don't know why that's. Yeah, the player doesn't need an action set. We're gonna get rid of this. All the player needs is a single queued action value. Just one. If we need it later, we can add it later. But for now, we just need one. So we'll just leave that to the side. No big deal. For the enemies, will need like a pretty sophisticated struct. It's going to be an array of like matrices, which is not going to be allowed to be stored because it's like an array of an array, and fucking Burst hates that idea for good reason. So what we'll do instead, we will make this a blob asset. Okay, we're gonna blob asset reference of type. I don't know. We'll figure out this is gonna be called burst compile. A public struct. We're gonna call it possible action matrix. Type iComponent data just for the memes, and then we will set it to, or it's going to contain so it needs to contain a world state that it starts at. Fuck, okay. I know what I need to look up. I've never implemented one of these, so I'm not familiar with it, but this is what we're gonna do. We're gonna look up how to write a search tree C#. That's what we're gonna write. Oh god. Fucking bright mode. Can you change that on incognito? Dark theme. Please, God. Device default is not set to bright mode. Thank you very much. Nice, I know. Alright. Yeah, C#, what do we search? C#, search tree. I think that's what we're looking for. It's like a branching thing, right? Or, actually, we can just look up that one wiki. Chess programming wiki. Because all we're doing is just the chess AI. Or just. We're just making a chess AI. Board representation. Maybe it's board representation. Make and unmake. So what the stage that we're trying to conceptualize is how to store the search part of this. Yeah. Okay. The search tree. Yeah. There's a subset of search spaces, a direct graph of nodes. Yep. Correct. This is what we want. The search tree contains various cycles, since both sides may repeat a former position with a minimum of 2 reversible moves each or 4 piles or plies. Cycles are usually eliminated and not searched twice, which results in searching a yeah. Okay, so this is something I was thinking about. That's good. It's good that it's mentioned. So the idea might be like, let's say that on the enemy's turn, it's considering swinging, and then it thinks that the player might dodge backwards. And let's also imagine that it considers the player is going to dodge backwards. Let's say the turn after that, it's thinking about the fact that it might move to the right, and the player might move forward, right? If the player does nothing, and then the enemy dodges right, we end up in the exact same world state because they never hit the player with the swing, and so then the player didn't have to do it. Now, obviously, in actual practicality, there might be like stat differences based on if I make missing a swing like cost stamina or something, but for what's actually happening on the board as we know it without any extra details, that is an identical board state. And so essentially what you would do is you would I'm blinking so hard. Fuck. You just cut out the duplicates. God, I don't know why that took me so long. I love losing train of thought midway through. It's awesome. All right, search space, search tree. I think we're doing a search tree. Yeah, this is what we're looking for. As part of the game tree is a dynamic hierarchical data structure or direct graph of nodes, also called vertices or states, connected by direct edges and arcs, or called state transitions that give a chess. Yep, correct. As opposed to the wooden plants, which are their similar structure metaphor for the search tree. Oh, thank you. I didn't know what a tree was. Okay. This is called an alpha beta tree. The root of this search tree is the position we will like to evaluate to find the best move. Yep. The search tree may contain various cycles, since both sides may repeat a form position with a minimum of 2 reversible each of 4 applies. Whether the search tree has to reside in memory, the whole search depends on which algorithm is used to traverse and expand it. So-called depth-first search algorithms like alpha beta start at the root and explore as far as possible along each branch before backtracking, and at least to keep one path from the root to the current position in memory. Best first approach is build a search tree by visiting and expanding the most promising nodes first. Okay, interesting. Minimal search requires optimal move ordering and alpha beta or its enhancements. Of course, this goal requires an oracle. The fuck is an oracle? Like a heuristic? Minimal search tree requires optimal move ordering and alpha, beta, or its enhancements. Of course, this goal requires an oracle, since we don't know the best moves in advance, otherwise we wouldn't search at all. Oh! Okay, yeah. Thus, rarely the expected node types don't behave as expected, but cut nodes don't fail high because their all node child fails high instead. Okay. Tree data structure. Yeah, this is what I want. How do I create this? How to create a tree. Okay, what is their example code? Private read-only dictionary of type string tree node. Okay. Oh, wait. Hold on. Okay, let's see if this would work. So they're talking about doing a dictionary, and then when you add something, you have like an ID for it in some regard, and then you just need to store your ID up and down one. I feel like we could do something similar, where if we have an array of, what would our ID be? Let's say bytes, because we should never have more than 255 queued in this thing. I don't think. Hold on, let's do some math. We actually might. Hold on. Let me not say that strong of a sentence. All right. If each action is stored in 9 possible vectors, not assuming rotation, just the possible input directions, and then we have 4 actions, that's 36 that we have to check at each stage. I don't know. I think they could get more. For now, I don't think we'll need more than what would be the next highest. A U short. How much is a U short? Its max is what, 16,000? C sharp integers. So U short 65,000. Okay, yeah, a U short will be plenty. We're never hitting over 65,000. If we are, we fucked up. We'll make a U short array, and this will be called our IDs. And then we'll do a similar blob array of something representing world state. Fuck, this is gonna get complicated. This was more than I anticipated doing in this fucking queue system. Let's do world state. We'll just put world state in here. We won't deal with anything else right now. Cool. So those are it. So the U short will match to a world state by the same index, right? So U short, or ID 0 is the same as state 0, right? That's how we'll do it. And so we'll just go here and we'll set this to a possible action matrix. Thank you. And then we'll add a single U short called optimal ID, and that'll just be what is the best action that it can take right now, and that way we can just, we'll save that separately so that if we change our mind or something, or if we only have one, then we're good and it'll be okay. But that's, I think, what we'll That's how we'll do this. So, and whenever this queue system goes to check it, it will just grab the optional ID on that, and then we'll be good to go. I think that's how we're going to do this. Okay, so we're going to change the actions. We don't need this line anymore. Let's go. Whoa, what is happening? Go back up. Can I go back a file? Thank you. Christ. Alright, let me make sure I'm doing this right in my head. So we're gonna build a blob builder. Don't need this line, actually. Just delete that. Okay, we're not building a type of turn queues. What even is it? Turn queue. I don't know this. Is it in here? Oh wait, it is the thing we're building. Okay, I forgot the name. So it's turn queues, and then we'll set it equal to new. Job equals new, state of complete. Oh, that's right, because there was a weird timing error I was running into. That's fine. Okay, so all we're going to do is we're going to go here, and we're going to I'm going to feed it fake data. So what we're gonna do is we're gonna have turn queues, set a queue job to new. How did I do this on the validator? I'm just gonna reread this. Oh, I should have made that its own function. I don't know what I was doing. Let's go here real quick. I want to do that real quick before I forget, because I hate how that looks. Void validate graph system state. And then we'll just take that and paste that over there. I hate when it does this. I don't know why it has such a hard time with tabs. Alright, delete. Oh, yes. Go one by one, please. Okay. So to reference, we made a new job. We set the job to the native array. We set the ID to the singleton. We constructed that inside this, right? Yeah, because we did it as an entity. And we should be able to do something similar here, right? We'll make a new one. But instead of setting action sets, we're going to do ref of queue data. If I remember correctly, putting in another component in this is going to require that component also exists on the object. But let me double check. Unit ECS passing components from another entity jobs. No, I don't want to I don't want access to component data in jobs. Here we go. Oh, this is outdated. Can we do like last? Yeah, let's do last month. There's gotta be something. It's not really last month, but it's the same fucking one. Oh god, kill me. Okay, pass entity array to object. Ooh. This might be it. This is outdated. Oh man. Maybe the documentation has it. Using the job system entities. Any type which implements this interface and also contains the execution method with any number of parameters will trigger source generation for corresponding iJump chunk or id. Okay, yes. So I think I'm right. If I added another parameter, then it's not going to work. I need to... Right? Hold on, let me double check my previous ones. Let me grab like turn system. Turn system no longer has jobs. Input system? No. Behavior system. That's just running on the enemy, so that's... Oh man, I don't remember. Fuck it. Let's try it. If we feed in what we need referenced is the no wait, I'm thinking about this wrong. I'm done. I'm thinking about this wrong. We need to iterate over every single prepared data, right? Because we're trying to make sure that they're all ready. So all we'll do is we'll just do feed in the action set, and then as a reference, we'll grab like a native list of turn actions. Okay. We need to be able to right parallel. So I think there's something specific you have to do to that, but let's see. We're looking for native array. Oh no, okay. No. Oh, is there not a parallel writer for that? Hold on, how do we do this? Write to native array paralleled. Oh wait, I didn't mean to have that open. Okay. God, it's late. My brain is fried. I don't know how much longer I can keep doing this. It's just too late. My brain is not able to comprehend. Let's do this. So the currently way to write a native array in parallel. You could use native queue as parallel writer, but the initial entities for each you'll have to compute the native queue into a native array in a separate job. Ew. With store entity query and field entity query to calculate entity count. An entity inquiry. Here's an example. Yes, give me an example. Okay. Partial struct job entity. We have a native array of colliders and a native array of type AABB. Okay, thank you. And then we're going to execute on entities. We have an int that is entity index and query. World transform, bullet transform, etc. Okay, what do? We have a variable called point B, which is a new float. We have a capsule collider, which is a new capsule collider built around point B. We have another float, which is our max. We have a capsule.point.a is that max. Okay. Bodies at entity query and index is equal to a new collider body. ABS equals that is equal to physics.add. Okay. I feel like I've tried something like this in the past and it's thrown me errors. But maybe it's not going to. And then is there, what do they call the job in here? Here. New job. Bodies is equal to bodies. ABS is equal to that. Okay. Now let's see what this is. body is equal to collection helper dot create native array of type count, and then state dot world update, and then native array options dot uninitialized memory. What is that? Fuck you. That is exactly what I want to do. Okay, awesome. Perfect. Good to know. Then we have the job. And then what do we do with these? So now that we've done that, we calculate them out separately. Then how do we get the count? Count is equal to query.calculate entity count. And query is a with all of that. Okay. So the proper way to do this, to make sure I'm doing this correctly, is when we go to queue in action, what we're going to do is this is called a queue action job schedule parallel. Okay, and then we're going to feed it a native array, and this one is going to be of, thank you, of type turn data. That's going to be our output. And so then what we're going to say is why is this? I don't care. Fuck off, please. Christ God. Stop getting in the way of my fucking pointer. Okay. That tag was called entity index and query. Okay. So we have the index, and then what we're going to do is we're going to... I'm trying to figure out how that combines with the blob builder. That's the part that's weird in my head. I'm trying to make sure I'm doing this right, because otherwise we're going to cause a bunch of fucking memory leaks. And I hate debugging memory leaks. They're so fucking annoying. Oh god, especially with the burst compiler, because you barely can follow the stack trace. So much fun. So much fun. Love it. Yes. Okay. What we're going to do is we're going to make a new blob builder. The allocator is not temporary. That's wrong. So we're going to set this to persistent. My voice is dying on me. The water is failing me. My voice has been fucked this last like week. Or 2 at this point. It's been annoying. Okay. turn queues is equal to construct the root, and then we have to assign, because if we go over here, yeah, we're gonna have to create the array. So what we'll do is we'll say go new line, ref, or no, let's do let's look at the input validator, because the input validator is the first time I've fucked around with this. VV.allocate that array. Okay. And that's where we'll get our count. And was that also a ref? Or was that? No. Okay. Blob builder array of type turn data. Data is equal to new blob builder array. And then we're going to do system API dot build query builder dot with any. We're going to specify that this is type needs to have black. What is this thing called? Action set. That's the name of the component. Action set. And then we're going to specify build dot, what was that thing called? Calculate entity count. Allocator dot temp job. I don't know. This needs to be persistent. Okay. What is the issue? Pointers can only be used in an unsafe context. Do I have to declare this as unsafe? I don't feel like I do. Query builder. Oh, maybe I could just remove the system API. Maybe that's the issue. Nope, not happy about that. Query builder with all dot build. Okay, maybe if I change this from with any to with all. I don't understand. It's not. I'm doing this example. What is the issue? How would I even? Pointers can only be used in an unsafe context. Giving quick and consistent access to buffers, components, time. This includes an such usage is. No, I don't want the data. This is supposed to be an account. It's supposed to be an int. Maybe it's just that. Cannot resolve constructor. Oh. Wait, I'm dumb. You don't pass an allocator in on this one. That's the issue. We pass in hold on. Yeah, that's my bad. That's the issue. Okay, we pass in the array reference. So in this case, it's going to be TQS dot value TQS is the turn queues. What we need to do is dot queue. I despise this fucking formatter. I don't know what is wrong with it. Oh, maybe it's just supposed to be TQS. Or maybe it's the blob builder. Hold on. We have the blob builder. Then we construct the root. Then we pass that. Oh, wait. This should be. Yeah, so we want this one. Nope. Okay, so what's the issue now? The type arguments for cannot be inferred from the usage. Maybe if I do TQS dot value here. Method group is not assignable to parameter int. Oh, yeah, because now I need to recall it because I cut that part off. Yeah. All right. That's the proper syntax because they're using a native array builder and we're trying to use the blob builder array. That's the issue. Okay. So now that we've created this, we also have to, because you can't pass a native array to a blob builder, we're going to have to create a native array of type turn data. And we're going to name it temp array. And we're going to set it equal to collections helper dot create native array of type turn data. And we're going to specify that it is we're going to cut this out. We're going to say int count is equal to yes, thank you for breaking my syntax again. Then we're going to go to the end. Put that, and then we're going to go down here, and we're going to do count, and then we're going to go down here, and we're going to do count. And then we're going to specify allocator dot temp. Okay. Then we're going to make a new line. And we're going to say, no, we're going to go here. And we're going to say date, or no, what is this variable called? Actions is equal to temp array. And then once Once those are all ran, then we're going to say, I'm trying to remember how you. Okay, I don't need to run this parallelize right now. We can just delete this. We'll just replace this with run. And then once it's ran, then we can continue the thread, and that's going to say for int I is equal to 0, I is less than count, I plus plus. Data bracket I is equal to temp array bracket I. Ooh. And then we're going to go to the end of this, and we're going to build it, I believe. Yeah. So we'll say system API dot get singleton read write of type q data dot value read write dot q is equal to bb dot create blob asset reference of type turn data allocator dot persistence oh wait, no, I don't pass it turn data, I pass it EQS. Or maybe I pass it churn queues. Did I do this right? Okay, hold on. TQS is equal to the construction root. Then we pass the, I think this is correct. So now all that needs to happen, which it's a little sloppy or doesn't really mean much in the grand scheme of things, is that at the end of the frame we're just going to dispose it, just because we haven't currently got to the because we're not currently storing it in between. We're just trying to test this out. QData dot Q dot dispose. Sure, we'll do a require for update. Alrighty, I think that's good enough to test. Let's make sure I had this right. So we're going to check state. And then once we check the state should always return to the queue actions section. And then what we're going to do is we're going to build a new blob builder. We're going to construct the root. We're going to figure out how many of them there's going to be. We're going to allocate out the array. Then we're going to construct the temp array. Then we're going to wait for the current job to complete if it hasn't already, because it was a weird timing issue. I'm gonna keep it for now, just make sure that this works, and then I'm going to delete it after to see if I still need it, but I think I will. Then we're going to queue actions with the temp array set to jobs. And then after it's over, we assign that temp array up to our normal array. And then we'll get that. Okay. So then to data test this, once you we're just going to say actions bracket I, or no, sorry, index is equal to new turn data, ID is equal to index. Oh, byte of index. Okay. Let's just make sure this cube works properly. And then I'm probably need to just chill for the rest of the night and pass the fuck out again. Because I am not mentally up for it. Alright, what are our errors? Attempt to access turn system data has been invalidated by a structural change. Did I change the turn system? Or did it say turn system data? What was in turn system data? No. Turn system data. I don't think I've touched this at all. That's weird. Every sample must have a subsequent in-call sample within the same frame. Oh, they're mad about the utilities function still. Okay, we have null reference exceptions. And what line? Q system 61. Oh, yeah, we're trying to check the length, and it's null. So what we need to do is check to see if q.value is not equal to null. No, what the fuck? Okay, why is this erroring? Cannot apply operand type not equals to operands of type turn queues and null. There. Now we'll do it to the array. The array should be nullable. How is the array not nullable? Okay. There's gotta be a way to do this. How to check size of array? Or no, that's a terrible Google search. Holy fuck, I'm tired. How to check size of blob? How to check if blob asset is nullable ECS? That's the. This is for mobile development. This is not what I'm looking for. So it looks like you can just do is equal to default. We'll see if that works. Why is that not okay? Cannot apply operators double equals to operands of type. Candidates are string and string or delegate. Okay. What if I delete you and I go up one on the chain? Can I do that? Same thing. Awesome. Okay, so then what the fuck? How do you ever check anything inside of this to make sure that it's properly set up? There's gotta be a property somewhere. Blob asset reference ECS. Yeah. Set it up to the current setup. No, not 1.2, 1.3. Thank you. Okay. A null blob as reference can be used to test if a blob. Oh, it's a property? So if I just say dot null. Okay, so it's just a reference to an empty one. So what it should say, the real test, is to say is equal to blob asset reference dot null. That's what that should say. Okay. Does this do this? Oh, add to. Hold on. I just realized there's a fucking bot in my. YouTube chat or Twitch chat. /ban. There we go. All right. We still got a no reference exception. Oh, we got it on cleanup. It's only for one frame, I think. Or no, it's pausing on error. That's the issue. We're going to disable error pause. Clear on play. Then we're going to hit play again. So they're going to happen every frame? Yeah, okay. Why is it happening every frame? Because the thing should last. So we set the allocator to persistent. Oh, I do need to clean up BB though. BB.dispose. And we're gonna get rid of this using because I've always seemed to have problems with it. That shouldn't fix the null exception. Yeah, it doesn't. Okay. But it does stop future memory leaks, so that's good. All right, and then why are we getting a null? Let's do a breakpoint. And then we should be able to see where the issue is. Unless it's happening before this runs. Hold on. Okay, we're reattached. Maybe disconnected. Hit play. Still not getting a hook in. Maybe it just doesn't like the curly braces. Okay, so we validate the system data. We're disposing that. Yep, fair enough. And then the next thing we're going to do is suppose this one. So then we're going to go into the other one. Queue system. Yep, and then we're going to go into queue data. We're going to go into that. Value is currently at null. All right. So let's hit continue on this. Now that we have the hookup properly enabled on the queue system, let's see if which one runs first. Okay, that's what I thought was happening. So what's happening is there's like a one frame where we are running the system where the queue system doesn't happen yet because the enemies haven't properly queued their thing yet, and then we're trying to dispose something that doesn't exist. So all we're going to say is we're going to go right into the next line. If we'll do the same thing we did. If, or, hold on, we'll just copy this line. Where is it? This line. Select the line. What was it? Shift V? Shift V. Copy it, and then we're going to go into here. And we're going to Shift V, paste. Okay. And then we're just going to change this to not equal. So now what will happen is, and this should also be not equal actually. Good, important catch. Oh wait. Fuck. Hold on. Did that mean that the queue actions actually was happening first? Oh no. Okay, wait, hold on. We have them both hooked in. Let's see what happens when I click play. Which one runs first? Please be the end cycle. No, it's not. Fuck. Okay, we screwed up somewhere then. Alright, let's go through them. So we make a new blob builder. EA for us. Then we set TQS equal to new turn queues. hasn't set anything in yet. Then we create two new data sets. So temp array has been set to length of 3. That's right, we do have 3 enemies in the queue right now. Alright, then what we're going to do is we're going to set the state dependency dot complete. Yeah, so we're going to check to make sure that everything's ready. Then we're going to run the job. We had an error. And then we're disposing. Well, that would explain the issue. Okay. QActionJobs.jobData.actions. Yeah. Oh, maybe this needs to be temp job because we're feeding it in. Okay. Let's turn off the checker just in case. Okay, reloaded everything. Okay. Alright, now let's check our queue. Oh my god, it's here. Just like we wanted. Alright. So, now we have an actual queue system. Now, the thing is, it doesn't currently take in the data because we haven't set up how the world state data currently works. So we could create some bullshit world state data. Actually, it's not going to be bullshit. That's what we'll do next. So I'm going to save this. Let's deattach from Unity. The blob asset reference is not valid. Likely it has already been unloaded or released. That's a new error. What line did that error at? 38. I don't think I disposed of that ever. Okay, so there's a memory leak somewhere in there. We'll figure that out next time. But the important part is, I'm blanking. God, I need to go to bed. Okay, the important part is we have a queue system that if it's given a valid set of data, we don't have that valid set of data yet for it, but given a valid set of data, it will set up the queue, and then the next thing we need to do is if the valid set of data is already there, then we need to do a process turn. So we'll do that later, because right now we're wiping the data every frame just to make sure that the test is still working. We're just constantly, right now I feel like a like an electrician or something, where I keep adding like plugins. Like, okay, at some point something will come through here to there, and at some point something will come through there to there, and at some point see A to B and D to F and etc. But I haven't actually like hooked up all the circuits together yet to run it through. So I think the next thing is we're going to hook up the enemy state. We need to set up the enemy world state data, feed that in. Then we're going to figure out how to do the player version of queue actions, because it seems like we actually do need to do that. And then we'll do then we'll hook it into the execution, and then we should have a through line that ignores the visuals, that cycles those through together. And then once that's working, we can hook in the visuals, add like timers to the visual, just like count X number of frames before you release, which so we don't have to actually like have like an animation ready. And then that should do the same thing, and then we'll just start finishing in that hook ins. I think is how we're gonna do this next. So we're about, I don't know, 4 or 5 functions away from having all the hook ins before the before the visuals. And once that's done, I probably won't even do the visual like animations yet. I'll probably start doing the data management of the of the map and getting that set up. And then once we have that set up, I'll make a visual of that, and then we can hook it in. But I want to make sure the data is valid first before we do that. All right, so let's save everything. I think we have a memory leak issue that we're gonna have to fix, or I'll fix tomorrow. We have a memory leak issue, and then let me make a note of this. Memory leak in Q system, Q actions, and then we're going to hook in the process turns, hook in the player queues, and then set up enemy world state data to feed to queue system. Okay, those are the next few tasks that we're gonna do. All right, if you hung around, thank you, appreciate you. Hope you all have a good one, and